that will leak, as they always have. We can expect a significant number of contamination incidents in water wells. That's the conclusion. Water well contamination is not a thing of the past, it's a predictable thing of the future. Next part of the talk, let's go to the global problem. Leaking wells put methane into the atmosphere, but that's not the only way methane gets into the atmosphere. And so what? What's methane in the atmosphere? What's that have to do with climate change? Okay, the next myth. Methane is a clean fossil fuel, or at least it's cleaner, and it's a bridge fuel to a green, sustainable energy future. We're going to use a fossil fuel to bridge over fossil fuels to get to a point on the other side where there's still fossil fuels. I'm a civil engineer, I know about bridges. That doesn't make any sense to me. Okay, we're here, we're an 80% fossil fuel economy in the United States. We want to get to 100% renewable economy sometime in the future, so we're going to build this extensible bridge out of shale gas and shale oil so that we don't fall into the shale gas and shale oil. Never mind. Some of you get it, some of you don't. Sorry. Sick sense of humor. What's wrong with shale gas and shale oil? Well, during the process of getting it out of the ground, storing it, processing it, pressurizing it, transmitting it, and using it, some of the methane, natural gas is mostly methane, some of it gets into the atmosphere. Either purposefully, by venting, and I'll show you videos of actual venting incidents, or because of leaks. All that gas has to go through pipelines. Has to go into storage facilities, processing facilities, compressor facilities, and there are leaks everywhere in that supply chain. And here's a list of some of those. So we're going to show some videos. I'm going to show you some videos of some of these incidents, occurrences. Here we go. First one is a compressor station. Remember, compressor stations take the relatively low pressure gas from a gathering line coming from a well and increases the pressure so it can be put into a transmission line and taken to market. No smoking. That's a high pressure methane emission coming from a compressor station. It's called a blowdown event. Blowdown events occur relatively frequently at compressor stations for various operational reasons. Blowdowns are not counted in the current EPA estimate of methane emissions. Next one is from a pipeline. So this is a transmission pipeline. It's operating at around 1,000 pounds per square inch. It's transporting gas long distances, large diameter pipes at high pressure. Frequently, those pipelines have to be inspected for cracking and corrosion. To do that, they insert what's called a pig. A pig is an electromechanical device that is inserted into the pipeline, travels along the pipeline, and detects corrosion and cracking. That's good. But if you have a pipeline that's 3 feet in diameter, operating at 1,000 psi, and you want to put a pig in it, how do you do that? Well, you have two valves, and you shut off this valve, and you shut off this valve, so that you can then inject the pig into the pipeline. But what happens to the gas between the two valves? So this happens every day. This video was taken from the back porch of a home in Greene County, a McMansion, very, very nice home. The pipeline happens to run right along the back edge of their property. Excuse me. And that's a venting incident. And you can actually see a guy walking around here. He's walking away from it. That one isn't counted by the EPA either. I'll show you this one first. I was there when we took this video. This is Susquehanna County. So this is a wellhead. I mentioned that there are about 9,000 shale gas wells that have been drilled in Pennsylvania so far. Only about half of them are in production. Some of the other half haven't been fracked yet. Some of those that have been fracked don't have pipelines yet, so they can't get the gas out of the fracked well to the market because there's no pipeline available. So over time, the pressure builds up in that well. And so every day, somebody, or every 2 days, every 3 days, somebody has to go out, open the valve, and relieve the pressure. What you just saw is methane emission from a non-producing gas well. There are hundreds of those in Pennsylvania. And finally, thank you, Lori. This was provided by Lori Barr, who's sitting right here in the front row. This is an example of a well that was abandoned sometime. And Lori's group went out and found the well and recorded its location, reported the location to PADEP to add to their database of abandoned wells. And they observed leaking from the well. So there's bubbling. So there's obviously methane coming out of that well. And according to research that was published this year by Dr. Mary Kang from Princeton University, she estimates that somewhere around 500,000, 500,000, one more than 499,999. I'm saying that for emphasis. Somewhere around 500,000 such wells, not necessarily all leaking, but about 500,000 abandoned wells are in your state, my state, Pennsylvania. We don't know how many are leaking because we don't know where most of them are. And for those that are leaking, we have no idea how much is leaking at what rate. And we don't know what's leaking. So if you want to pay the bill for answering those questions, let me know. But they're important questions to answer because this is all adding methane load to an already overloaded atmosphere. Okay, so what about methane? Why is it important? Why do we need to know what all these venting and leaking events are doing? It's important to know because methane is a greenhouse gas. So when the industry says methane, natural gas, is a cleaner fossil fuel, they're correct in one sense of the word. They're correct in that when you burn natural gas, you get less carbon dioxide emitted than if you burn oil or coal. Perfectly true statement, scientifically valid, supported. What the industry doesn't tell you is that there is another greenhouse gas associated with shale gas and oil, which is worse than carbon dioxide, and that's methane itself. So back in 2011, two colleagues of mine and I published a paper in which we did an estimate, not an actual measurement, an estimate based on then available data of how much methane was leaking purposely or accidentally into the atmosphere without being burned. And we compared that amount of methane coming from shale gas, from conventional gas, from coal, and from oil. And this is a complex chart, so let me make it very simple for you. Here are 4 fossil fuel uses, and this vertical axis is a measure of impact on climate. The higher the bar, the worse it is. So when we did this paper, all we could do was estimate. There were no data. No one had gone out yet in 2010, 2011, and actually measured how much methane is getting into the atmosphere from oil and gas operations. We didn't know. All we had were estimates. So based on the available estimates, we estimated it could be this much impact on climate. It could be that much impact on climate. This magenta color is methane, the blue is indirect carbon dioxide that you generate from running diesel engines and trucks, and the black is the direct carbon dioxide you get when you burn it. So as you can see, when you burn natural gas, you get less carbon dioxide than when you burn coal or oil, but we're saying the methane emissions are much higher, and we said that the leakage rate, how much methane is leaking, either purposefully or accidentally, is somewhere between 3.6 and 7.9% of all the natural gas produced in the United States. Let me rephrase that. Repeat it. Of all the natural gas produced by oil and gas operations for shale in the United States in 2011, when we had no data, only estimates, we said the answer is probably somewhere between 3.6 and 7.9% is getting into the atmosphere as a greenhouse gas. Remember those numbers, please. We were loudly criticized by a variety of parties, including academics at some prestigious universities in Pennsylvania, for saying such outlandish things. How could 3.6 to 7.9% of all the methane, all the natural gas being produced in the U.S. from shale be leaking into the atmosphere somehow? Okay. So, in the last 4 years, the three important questions related directly from our paper. We asked these questions in our paper. How much is leaking? That's a technology question. If you want to know how much water is dripping out of your faucet, you don't have to do a scientific investigation. You don't have to develop policy. You measure it. Put a measuring cup under, get a watch, and you can say 1 quart per minute, or 1 quart per hour. It's technology. Go out and measure it, except this is really difficult to do. How do you go out and measure how much methane is getting into the atmosphere from all the oil and gas operations in the entire United States? Nobody had done it. But since then, a lot of people have tried, and I'm going to tell you what they found. That raises a second question. Given whatever amount of methane you find that's leaking, what impact does it have on climate? Is it negligible? Is it as important as carbon dioxide? Is it more important than carbon dioxide? And depending upon the answer to those questions, you then have a policy question. What should we do about it? If it's negligible, you don't have to do anything. If it's about the same as carbon dioxide, then you can't just talk about carbon dioxide, you have to also talk about methane. If methane is more important than carbon dioxide, forget about carbon dioxide, let's work on the methane problem. Those are policy questions. Those are decisions made in the White House and the Congress of the United States. So we're going to address each of these briefly. All right, how much is being emitted? Prior to 2011, it was all guesswork. The EPA would ask oil and gas operators to estimate how much methane they were releasing. And that was reported to the EPA, and the EPA reports it to Congress and the United States people. That's how it worked. Still works today. EPA does not go out and measure methane. Never have, never will. It's not their job. But others did. National laboratories and other government agencies. NOAA, National Oceanic and Atmospheric Administration, some of our national labs, and many professors at various universities went out and started making measurements. I'll summarize them. Utah, 9%. Around Denver, between 2.3 and 7. Remember, our numbers were here. Natural gas leaks from pipelines, including distribution lines under the streets of our cities. This is a graph taken from a paper where they studied the leaks in the pipelines under Washington, D.C. How do you interpret it? In this room right now, we're all breathing methane. About 1.9 parts per million of every breath you take is methane. That's called the natural background level, the baseline level. These numbers are in parts per million as measured. Every one of these bars is higher than the background, and in some cases, 25 times higher. Similar studies have been done in New York City most recently, in Indianapolis, and in Ithaca, New York. So we have leakage from pipelines too. 2 years ago, we decided to do our own study. We at Cornell teamed up with people from Penn State, Purdue. Our colleague at Purdue has a private airplane. He put a very sophisticated hydrocarbon gas detector in the airplane, and we flew over the southwestern corner of Pennsylvania, notorious Greene County, the most poked, prodded hydrocarbon-producing place in Pennsylvania. We flew over it, and we measured methane in the atmosphere. Just like they measured along the streets of Washington, D.C., we measured it from the air, flew around. Here's the box of Greene County, and this is the flight pattern. And the colors correspond to methane concentration measured in the atmosphere. Remember, this is natural. This is what we're breathing right now in this room. And we found concentrations as much as double that. And when we back calculated how that could possibly be, given that in Greene County there are cows producing methane, there are landfills producing methane, there are coal mines producing methane, there are old oil and gas wells producing methane, and there are new shale gas wells producing methane. We have to isotopically separate all that and figure out which methane is coming from which source. which we can do. And we found out that somewhere between 4 and 12% of all the natural gas being produced in Greene County on the 2 days that we made those flights was getting into the atmosphere, between 4 and 12%. More recently, using satellite observations, European scientists have created this chart. So this is the leakage rate in percentage. This is the range that we predicted, 3.6 to 7.9.